Today we're going to look at 3.6, solving quadratic inequalities. The essential question for today is how can you solve a quadratic inequality? Now remember, inequalities are greater than or less than problems. So, first method for solving a quadratic inequality into variables is to graph the parabola. Make sure to use a dashed line if less than or greater than. Make sure to use a solid line. If it's less than or equal to or greater than or equal to, then you pick a point and you shade the true region. So we're going to do one example of these. So y is less than negative 3x squared minus 2x minus 1. Okay, don't worry about the inequality to begin with. Realize that is in standard form. A is negative 1, B is negative 2, and C is negative 1. Okay, so in standard form to graph, we use x equals negative b over 2a. So negative and a negative make a positive 2. 2 and negative 1 make a negative 2. And 2 divided by negative 2 is negative 1. So if you remember back to do standard form, now what we do is we take this number here and we substitute it back into the original equation. So negative 1, parentheses, negative 1 squared minus 2 times negative 1 minus 1. You do the math for that, you get negative 1 squared, which is 1, times a negative, which is a negative. So negative 1 plus 2 minus 1, you get 0. So our vertex is going to be at negative 1, 0. So I place a point on my graph at negative 1, 0. Then I make my table for my stretch. X, I just pick a couple, 1 and 2. Square them, 1 and 4. Multiply by the a value, negative 1 and negative 4. So remember the middle's trash, so we're going to go 1 over, 1 down. We're going to reflect that. We're going to go 2 over and 4 down and reflect that. Now, I look at my graph and it doesn't say equal to, so it's going to be dashed. I'm going to kind of do dotted here, the best of my capabilities. Put some arrows on the end. It's going to be easier to do dashed, of course, on your paper. Remember, basically what this means is if I pick any ordered pair on that parabola, it will not work in the original problem. Then we're going to pick a point. The easiest point, of course, is 0, 0. 0, 0 exists on the exterior of this graph. So I'm going to take my equation and I'm going to plug it in. Is 0 less than negative 0 squared minus 2 times 0 minus 1? Well, if I do the math, I get 0 is less than negative 1, which is not true. It is false. So 0, 0 does not work. Since 0, 0 does not work and it is on the outside, I have to shade the interior of my quadratic. Remember, the arrows means it extends forever. The shading represents the interior is where I could find any solution that would work in this problem. Okay, let's apply this to math. It says a manila rope used for rappelling down a cliff can safely support a weight in pounds provided where D is the diameter of the rope. So we're comparing the weight of a person to the diameter of the rope. And if you think about it, basically the more a person weighs, probably the larger the diameter of the rope is going to be. It says graph the inequality and interpret it. So here's my equation that they give me. Now, what that means is the weight is less than or equal to 1480 times the diameter squared. Now, this is, you could do standard form, or you could realize this is just vertex form. It's like saying 1480 times the quantity d minus 0 squared plus 0. So what this means is 0, 0 is where I'm going to start my graph, which makes sense. You don't need a diameter to your rope if you weigh 0 pounds because you do not exist. My stretch is 1480. So I'm going to multiply everything by 1480. 1, 2, 3, and so on. So if I have something that has a diameter of 1 inch, okay, square that, we get 1 times that 1480. So when 1 inch rope is going to turn around and hold somebody up to 1480 pounds, 1,480 pounds. I do the same for 2. 2 squared is 4 times 1480. I get 5,920. 3 squared is 9, and 9 times 1,480 is 13,320. So I come up here in my graph and I plot that point 2. So if you look, it's not linear. The graph does say equal to. So to the best of your capabilities. Now, you might be asking yourself, this is a horrible parabola, I know. Why did you not reflect it? Okay, you got to remember the diameter is your x value. Are you ever going to have a negative diameter on a rope? No. That's why we only need the first quadrant here, because we don't need to worry about the negatives, because we're never going to have a negative weight, and we're never going to have something that has a negative diameter. So it says you want your weight to be less than or equal to, okay, 1480. So if I pick a point, say I pick 10, 0. If I put 10 in there, 1,480 times 10 squared, of course that's going to be bigger than 0. So the answer lies underneath. Now, what does that mean in relationship to our graph? Okay, this is kind of like the boundary line. This is the most your weight, your rope is going to handle, the maximum weight. So the shaded region down here represents the weight that can be supported. So for example, if you have a diameter of 4, you can support anything up to 2,000, probably 3,000, even close to 4,000 pounds. But so if you have a diameter of 4, you cannot support something that's 14,000 pounds. It will snap the rope. I hope this makes sense. So example 3, what we're going to do is we're going to start throwing them together. So we're going to have 2 inequalities. So when I look at the first 2, and I noticed that there's no parentheses, they are both quadratics. So for number 1, I look and I say, well, I could do x equals negative b over 2a and all that fun stuff, or I could realize this is in vertex form. They didn't add or subtract anything to x, and the ending number is 3, so my vertex is at 0, 3. So I plot a point at 0, 3. Then I make my table, 1, 1, 1, and 2. My a value is negative 1, so I'm going to go 1 out and 1 down. I'm going to go 2 out and 4 down. I look at my graph and it does not say equal to. So that means when I draw this in, as bad as this looks, it's going to be dashed. And same for the other side. So my graph looks something like that. Okay, so now I need to test a point. Well, 0, 0 is inside it. So let's test 0, 0. Is 0 less than negative 0 squared plus 3? Well, yes, 0 is less than 3. So that works. Grab a highlighter. I'm going to shade inside because 0, 0 worked. Nothing different. Now we're going to do the same process, but we're going to do it with the other graph. So I'm going to grab a different pen. This time I'll just use black. First I got to do a selection. Okay, the second one has ax squared plus bx plus c, so I got to do it in standard form. So b is 2, so it's x equals negative b over 2 times a, so I get negative 1. Okay, take -1 and plug it into the math problem. -1 squared plus 2 times -1 minus 3. I get -4. So my vertex is at -1, -4. So 1, 2, 3, 4. Now this graph also is positive, so it's going to open up, which is nice. I make my table. My A value is 1, so I'm going to go 1 out, 1 up, 1 out, 1 up, 2 out, 4 up, 2 out, 4 up. Now what's different, I only went 3 up, that doesn't help you. 2 out, 4 up, 2 out, 4 up. Okay, this one is solid because it says equal to, so I got to draw it in solid. Okay, pick a point and test. 0, 0's inside again. I could test that one. Okay, is 0 greater than or equal to 0 squared plus 2 times 0 minus 3? Well, is 0 greater than or equal to -3, which it is. So that's true. So once again, this time I'm going to shade inside. Now remember, the answer to the math problem isn't what's separate, it's what's in common. So in my case, the answer to this math problem is right in here because that is where my two graphs overlap. If I pick anything on the solid line, it will work within this region. If I pick anything on the dashed line, it will not, but anything inside will work in both of those. Okay. Example 4, what we're going to do is we're going to solve algebraically with one variable. Okay, so to do so, notice there's not two variables, so we can't just graph them. Okay, we're going to have to do a little bit different. So, step 1. Make sure it's equal to 0, which is it's less than 0, and then either use the quadratic formula, factor it, complete the square. I just factored it because it was an easy one. Factors of -4 that give me a -3. Well, that's -4 and +1. Then you set each piece equal to 0, so if you did the quadratic formula or completed the square, you still would get 4 and -1. Now what is different is there is no y value, but it is an inequality, which means instead of a specific definite answer, it's going to have an infinite answer, so to say. So what you have to do is you have to graph it. So to start with, we're going to place a point at 4 and -1. Now since it says less than and it doesn't say equal to, remember way back when, since it doesn't say equal to, they're going to use open coordinates. So 4 and -1. Okay. Then all I have to do is take my original problem before I factored anything and test some solutions to figure out where it's true and where it's false. So the first number I picked was something to the left of -1. So I picked -2. I substituted -2 into the original equation and I got 6. Well, I know 6 is not less than 0, so that is false. I'm just going to write F up here for false. So anything over here is false because -2 didn't work. Okay, do the same process. I'm going to pick something between the two. Well, I'll pick 0 because that's an easy one. 0 squared minus 3 times 0 minus 4, is that less than 0? Was -4 less than 0? Well, that's true. So this is true. Okay, so now I do another value. Maybe I'll pick 5. Okay, 5 squared minus 3 times 5 minus 4. I get 6. 6 is not less than 0, so this is false. So then we shade where it is true. In this case, it is true. I'm going to grab a line here. Between -1 and +4. That's the only place it's true. Now to write this in normal notation, what we would say is we would say, hey, x has to be greater than -1 but less than 4. So what we do is we sandwich in between the two. Notice that the sign doesn't say equal to, and the sign should match my original problem, which it does. And I'm going to say x is between -1 and 4, but we do not include -1 and we do not include 4. Now, if you wanted in an interval notation, it'd be parentheses -1 comma 4 parentheses, but we're just going to write it with an inequality. Let's try one more. So this one, when I encountered this one, I said, well, it's not equal to 0, so I got to move everything. Well, the problem is with an inequality, negatives get kind of messy. So what I decided to do was move everything to the right first. Now, what happens when you move everything to the right is it looks a little backwards. So what I did is I used the symmetric property. I just flipped the entire equation over, kind of like, or inequality, kind of like a flapjack. Now, I can then factor, so, or I could FOIL, or I could complete the square, but I decided, this one I'm going to use the quadratic formula. So x equals -b plus or minus the square root of b squared minus 4ac all over 2a. I substituted that in. I simplified it. I got the square root of 28. Well, we know the square root of 28 is 4 times 7, so it's 2 squared to 7. Now, in order to put this, unfortunately, on a number line, you do have to have a decimal approximation for it. So in order to do that, you can reduce them all by 2 before you start, or you don't have to. In your calculator, you take -4 plus 2 squared is 7. Hit equals, then divide by 6. You get a -1.55. Excuse me. Positive 0.22. You repeat the process and you get a -1.55. So those are the approximations that I'm going to put. If I wanted the exact answers, I would write those on there, but I just need to know approximately where they're at. So 0.22. Now this one did say equal to, so it's filled in. And -1.55. And that just by using the decimal point, that gives me an approximate answer of where it's going to be. Okay, so now we repeat the process. I pick something to the left. Well, once again, I picked -2. Ooh, I did that one wrong. Unlock. Okay, so I'm going to put -2 in here. Mark this out. Now I'm going to plug it into this one right here. So 3 times -2. Well, -2 squared is 4. 4 times 3 is 12. Okay, that's fine. So we have 12. Okay. Plus 4 times -2. Well, 4 times -2 is -8, so that's -8. Minus 1. 12 minus 8 is 4, minus 1 is 3, and the last time I checked, 3 is still greater than or equal to 0. Now, the problem I actually plugged in was 0.22, and reason being that was the actual point. I should have picked up something less than that, so because otherwise it would equal to that. So, I know that if I plug in a -2, I get a 3, which is greater than 0, which is our goal. So -2 works, so this time it's true out here. Okay, I'm going to repeat the process, hoping there's no other mistakes. This time I'm going to test 0 because it's between the two. 3 times 0 plus 4 times 0 minus 1. Well, I got -1. And I know that -1 is not greater than or equal to 0, so that is false. So we're good there. Okay, so now I'm going to do my next value. So I'm going to pick something bigger. I'm going to pick 2. Now I picked 5, actually. Tells you how great my day is going. Okay, so if I do 5, which is to the right, I get 94. And 94 is a lot bigger than 0, so that is true. So this time, instead of being true between the two, where they are true are on the exterior parts. So over here and over here. Now you do want to draw in your arrows saying, hey, it does include these, so it's going to go forever. So that's how we would graph it. since it doesn't have two variables. Then how we would write it is we would say x is greater than or equal to 0.22, or if it wants the exact, x is greater than or equal to -4 plus 2 square roots of 7 over 6, or -2 plus the square root of 7 over 3 if you simplify it. Same case with the negatives. Notice it's not in between the two. Okay, the next one we're going to do, we're going to solve by graphing. Sometimes you can use your graph to help you. I do want you on the ones where it says solve algebraically to solve it out. But to graph them, it's done a little bit differently. What you can do is you can graph them, even though they're not two variables. So what I did was I graphed this lovely graph, noticing that it is equal to 0, so I just replaced it with equals y. Now, all I have to do is to figure out which side of the graph to shade. So we pick a point, just like we would normally do. 0, 0 inside is 3 times 0 minus, or 3 times 0 squared minus 0 minus 5 greater than or equal to 0. Well, 3 times 0 squared is 0 minus 0, 0 minus 5. That's not true. So what it would be normally, if we wrote it in two variables, is it would be on the outside. Now here's the catch. It's not on two variables. So what it is asking for in the graph is where are your x values, since there's no y's, where are your x values shaded in? Well, my x values are shaded in starting over here and to the right, and over here and to the left. So what that means is that my answer is either less than -1.135 or greater than or equal to 1.468. So that is how you can graph using Desmos to help you figure out the answer. You just need to decide on whether you want in between the two or if you want the outside. And the easiest way to do that is to test a point. Now, the last example we are going to do today requires a little more thought. It says a rectangular parking lot must have a perimeter of 440 feet and an area of at least 8,000 square feet. Describe the possible lengths of the parking lot. So it doesn't want to know anything about the width. It just wants to know about the length. So the perimeter, if you remember back, is 2 times the length plus 2 times the width. So we want it to be exactly 440. And then we want our area to be at least 8,000. So what we would say is our area, since the rectangle's length times width, has to be greater than or equal to 8,000. Now, it said describe possible parking lot lengths. Okay, so this one, when you encounter a problem like this where there's an equation and an inequality, what you want to first do is rewrite your equation. Now you want to rewrite it in one variable. And since this says it wants to know about the lengths, we need to first start by taking that first equation and solving for W. Reason being we want it in terms of L. So I subtracted over the 2L, I got -2L. I divided everything by 2, I got -L plus 220. Now, we want possibilities, which means we got to go with this formula over here. Somehow I need to put this formula on the left into this formula on the right. So that's what I did. Where I saw width, I put in -L plus 220. Now, this gives me possible lengths, but unfortunately, it's not really helpful at this point since it has an inequality. So I decided maybe I need to solve this. So next, what I did was I took it and I distributed, and I moved the 8,000 over. Reason being I wanted it equal to 0. Now, I could either use the quadratic formula, I could complete the square, which might get kind of messy. I can maybe factor it, or I can graph it. Well, let's just do what we did before. Last example, we graphed it. So I graphed that lovely thing right there. Y equals negative, instead of L, I used X. Negative X squared plus 220X minus 8,000. And I got these two values. Now those are my two X intercepts. Okay, so now I have to think about this. I want it to be greater than or equal to. So I'm going to pick like 0, 0 and test it. So I'm going to plug 0, 0 in this. Length times width. Because L's my length, W is my width. Is 0 times 0 greater than 8,000? Well, no, of course it is not. So 0, 0 does not work, so it's what is inside that counts. So if you look at just the X values, we want the X values inside that parameter. So what we could say is that my length has to be between about 45.97 and 174.03, give or take. Now, if they just want the lengths in whole, because I don't think you would want to measure it, what we could finally say, see if my computer screen will let me extend, is the length has to be between 46 and 174. 46 just being slightly bigger than 45.969 and 174 being slightly smaller. So putting it in those parameters. So those would be your options for your length. It doesn't want to know anything about the width. All it wants to know is about the length. If it wanted to know everything about the width, the reverse would have been true. Instead of having L's here, you would have W's. Instead of solving for W, you would have solved for L. So I hope this has been helpful. This actually does have a real life application. If you're looking at building a fence, those types of things around properties, or making parking lots. So I hope this has been helpful, and I will see you next time.